All right, let's dive in. Today, we're going to break down the digital address that makes the whole internet work, the IP address. It's the reason an email lands in your inbox and not your neighbor's. It's how Netflix knows where to stream your movie. So how does this whole critical system actually work?
So let's just start with the main puzzle here. Think about it for a second. There are billions of devices out there, computers, phones, servers, even smart fridges, all connected at the same time. When you type in a website, how on earth does your device navigate that massive digital ocean to find the one correct server, and then get the information all the way back to your screen? It sounds kind of impossible, right? But the answer is actually surprisingly simple.
The solution to that whole impossible-sounding problem is built on a really powerful idea that we all get from the real world. For anything to get anywhere, it's got to have a unique address.
The basic idea couldn't be simpler. If you just wrote a name on a letter and dropped it in a mailbox with no street address, what would happen? It would just get lost, right? The Postal Service would have no clue where to send it. Well, the internet works the exact same way. For data to find its destination, every single device needs its own unique digital street address.
And that digital address is what we call an IP address. It stands for Internet Protocol Address. And this number does two really crucial things. First, it identifies a specific device, and second, it tells you its location on the network. That way, all the little packets of data know exactly where they're supposed to go.
So, okay, we know it's an address, but what does one actually look like? There are a couple of different versions out there, but the one you'll see most of the time is super simple and easy to spot once you know the pattern. This common format is called IPv4, which is short for Internet Protocol Version 4. It's just 4 groups of numbers separated by dots, and each of those numbers can be anything from 0 all the way up to 255. It's a simple structure, but it's what originally gave us over 4 billion unique addresses for the entire internet.
And here are a few real-world examples you might actually bump into. That first one, 192.168.1.1, that's a super common default address for home routers. You might have even seen it before if you've ever set up your Wi-Fi. The other two, like 8.8.8.8, those are public addresses owned by a huge company, in this case, Google. The key thing is, every device, every server out there has one of these.
But here's where it gets interesting. There's a little twist. You see, not all IP addresses are created equal. In fact, to keep everything organized and secure, they're split into 2 very different types, public and private.
The best way to get this is to think about an office phone system. Your public IP address is like the main phone number for the entire company. It's the one globally unique number that the outside world uses to call in. Your internet service provider, your ISP, gives you this one. But then inside the office, you have private IPs. These are like the internal extensions for each employee, like extension 101, 102, and so on. Your computer, your phone, your smart TV, they each get a private IP from your router. They can all talk to each other inside your home network, but the outside world can't see them directly.
Which, of course, brings up a really good question, right? If your laptop only has a private extension that the big, wide internet can't even see, how does it get online? How does it ever browse a website or get an email? How does it make that jump?
Well, the answer is a really clever process that your router is handling for you all the time without you even knowing it. It basically acts as a digital gatekeeper for your entire home network, and it uses a cool piece of tech called NAT. And this little bit of magic is called Network Address Translation, or just NAT. It's actually a pretty simple 4-step dance. Step 1, your computer with its private IP asks your router for a website. Step 2, your router takes that request but sends it out to the internet using its own public IP. Step 3, the website sends the information back, but it sends it to the router's public address. And then step 4, the router, which cleverly remembered which device asked for it in the first place, forwards that information right to your computer's private IP. It happens in a flash, millions of times a day.
If that's still a bit fuzzy, here's another great way to picture it. Think of your router as the manager of an apartment building. All the mail for everyone who lives there gets delivered to one single street address. That's the public IP. Then the manager, who is our NAT, looks at each piece of mail, knows exactly which apartment it's supposed to go to, and delivers it to the correct door, the private IP.
Okay, so that's enough of the theory. Let's get practical for a second. How can you actually go and find these 2 different IP addresses for your own network? It's actually way easier than you might think.
Finding your public IP is the easiest thing in the world. Seriously,
Just open up a web browser, go to Google, and type in "What is my IP address?" The number that pops right up at the top, that's your router's public address. It's the face your entire home network shows to the world.
Now, finding your private IP just takes one little extra step. If you're on a Windows computer, you can open up something called the commands prompt and type ipconfig. On a Mac, you'd open the terminal and use a similar command. But for your phone, it's even easier. You usually just go into your Wi-Fi settings, tap on the network you're connected to, and all the details, including that private IP address, will be listed right there.
All right, so there's one last important detail we need to cover. Are these addresses you get permanent or do they change? Well, the answer is, it depends on which kind you have.
Most of us at home have what's called a dynamic IP. This just means our internet service provider might give us a new public IP every now and then, a lot of times just when we restart our router. It's just an efficient way for them to manage their pool of addresses. On the other hand, servers and businesses usually pay for a static IP. This is an address that is permanent and never ever changes. And that makes perfect sense, right? You need a website's address to stay the same so you can find it reliably every single time.
So let's just do a super quick recap of the main points. An IP address is basically a unique digital address. You've got public IPs for the big global internet and private IPs for your own local network at home. Your router uses that magic process called NAT to translate between them. Most of us have dynamic IPs that can change, while servers need those permanent, static IPs to be reliable.
And that leaves us with a really fascinating final question. We've just figured out the whole addressing system, how computers manage to find each other anywhere in the world. But what about the data itself? How does an entire web page or a huge video file actually get sent? It doesn't travel in one big piece. It gets broken down into thousands of tiny little packets for the journey. And how that works, well, that's a story for another time.